Okay, what do you guys think the magnetometer does? Well, okay, meter meaning what? Come on, guys, use your knowledge here. Measurement. Good. So what are we measuring? Magnetism. There we go. That's exactly it. By the way, metal has magnetism in it, right? So if we could use this magnetometer, we could detect metal under the water. Again, what does that help us do? Helps us find the subs underneath the water. So again, this is another technological advance that help us with anti-submarine. And so basically, we developed this device and it measures changes in the magnetic fields. That's all it does. This one gets really weird. I want to be the poor guy at the Department of Defense whose job it was and made this discovery. This is actually a really neat discovery. So basically you have the magnetometer and it's measuring on these magnetic fields. And again, they're making maps of the fields. And basically, these fields are from the iron-bearing minerals. Early on in the semester, we made a really feeble attempt at reading a compass. You guys remember that activity? We got to go outside, and I got to watch you guys wander around in circles, not having any clue where you're going. Okay? And it's because this compass actually relates quite well to this lesson and to the magnetometer. The needle inside this compass is made out of what mineral? The needle. Iron. And iron readily aligns itself to the magnetic North Pole. And so what happens is, as this liquid in here basically allows the needle to be free flowing, the needle will automatically align itself to due north. So now imagine that we have this fluid, and the needle is able to rotate freely in the fluid. So what happens when that fluid solidifies? What happens to the needle? It stays. It no longer moves. It gets frozen in place, right? So we have the same concept working here, where you have the needles of the iron basically aligning themselves to the magnetic North Pole. And when it does that, you get this really surprising outcome. So just like we said here, as basically we had new magma coming on onto the surface, the iron minerals within that okay, so iron minerals within that within the magma align themselves to due north, and then as that magma cools, they become locked in place. So let's see what happens here. So once we take all the readings then from our magnetometers, we get this really interesting outcome. What do you guys notice about the ocean floor? Okay, so let's go this again. So the white areas, those are your normal polarity. The blacks are your reverse polarity. Basically, right? So our normal polarity means it's facing north. The black is facing south. Well, what do you notice about the pattern? That looks like a barcode. They're basically alternating back and forth, right? And now what happens if I look at it from this direction? What do you notice on both sides? It's the same pattern, right? It's basically an image reflected on the other side. So this really helped scientists develop this theory of seafloor spreading. We start looking at this, we see these alternating things. Now this actually goes in deeper, way deeper than you can imagine. Because of this, what this ocean floor is actually telling us is that the polarity of Earth flips on a regular basis. We still don't understand how it flips. We don't understand why it flips. We do know that there's evidence that it flips. And it flips all the time. And does it fairly quickly. So that's just something I want you guys to keep in mind with that one. Now, when we look at these strips, we call this paleomagnetism. It's where we're basically studying the ground and studying the magnetic fields over geologic time. And what the scientists couldn't figure out is, again, basically why, what caused what they were seeing. And so this is something that, like I said, took us a little bit of time to figure out here. Scientists are pretty good at looking and observing, but then they actually have to go back and look at what's really going on here. What are we really seeing that's telling us a lot of information?